500 million of people, they're actually depending from food production of the coral reef. So it's not just going to be a biodiversity disaster, but also an economical disaster for humankind. Thank you so much. I would like to introduce you to a new way of combining the production of concrete to go hand in hand with nature restoration, and how we do that at Coastruction. Maybe you know that underwater in our ocean there is a multitude of really complex biological ecosystems, which they're really fundamental for the health of our planet. Just a fact, coral reef are one of the most complex of them, and they are housing 33% of all marine life present in our oceans, despite they cover only the 1% of the planet's surface. And another fun fact is that the corals are actually animals, and they're living through collaboration with other animals in the ecosystem of a coral reef. So it's really fundamental, the balance between all these pieces to have a healthy environment. Corals are also very important for coastline protection because they reduce of 97% the energy of the waves. So they're really fundamental for preventing flooding and erosion of the coastlines. Half of a billion of people actually depends from food production from coral reef. So they're really fundamental for human beings. They're in danger, as you know. All our oceans are in danger. We lost already 50% of them. And if we don't act now, we're going to lose more than 90% by 2050 of all coral reef. The consequence of disappearing these ecosystems, together with other ecosystems, like, for example, mangrove forests, which are also essential for coastline protection, the consequence they're going to be like flooding and loss of livelihood for a lot of people. 500 million of people, they're actually depending from food production of the coral reef. So it's not just going to be a biodiversity disaster, but also an economical disaster for humankind. We have few solutions for restore our ocean, and one of them is artificial reef. So actually it's an artificial substrate that allows marine life and special corals to grow back and allows to have a substrate to grow back. Mainly the production of artificial reef is made in casted concrete. But there are other solutions like, for example, metal rebarring or clay production out of 3D printing as well, but mainly casted as well. But as you can see, of course, the casted technology doesn't really allow a lot of freedom of shapes, and the shapes are quite geometrical and bulky. But the problem is that they don't address the need of the complexity of those ecosystems, and they don't address multiple solutions at the same time. But you have more one direction on one species or one needs that the ecosystem need to be restored. For example, a story. Corals, big coral reef to be relocated, kilometer of corals relocated on artificial reef with a big project. After 1 year the project was done, they came back on the location and they found out that the big fish, like sharks, they took over the area because they were more suited to live through big structure. So small fish, they weren't present anymore, and as a consequence, all coral reefs, they were actually lost. So big project that was actually a big failure. So let me propose to you a new way to do artificial reef in a way that can go hand in hand with nature and can think of the ecosystem as a whole as a solution and addressing multiple problems in the same solution, because we can have complex and unique and different shapes. Let's be honest, nature doesn't care about humans. The humans really need nature. So let's proposing this new tool to approach this new solution with our technology to create a structure that are actually easier overgrown, like you can see in those examples. These are 3D printed artificial reef that they are being installed in the sea. Actually, this one is in the Netherlands, in the north. How we do that? We use 3D printing technology. We use extrusion, which is the most common one. We use powder bed 3D printing. Is a technology that allows freedom of material and freedom of shape, because it works with depositing layer of powder and selectively pouring a liquid binder where you need your structure to come out. So layer by layer, you have your object in a container full of materials, and then you can clean it out and take out your object. This allows us to have a process that doesn't have any waste, is more sustainable, and is also circular. We already have our Idofix, which is our small prototype, is up and running already at our clients. And right now we are busy in developing Asterix, which is going to be our scale-up 1 cubic meter machine. And our Vision 3D printer, it will be transportable, large scales, up to 6 cubic meter capability of printing, which we call it Obelix. So freedom of material is really essential for us because we want to address the needs of each location and each different ecosystem. So we can use different powder, for example, recycled concrete already. It could be used in our technology. We already done a few tests and it's actually working very nicely. Together with crushed shell, which actually help the nature and the overgrown of different species. Or itself using aragonite sand, which is the leftover itself of the corals. You can add it in our mix and create artificial reef that they can allow corals to grow faster and healthier. And all these aggregate, we mix it with cement. But our technology doesn't really limit it, the use of cement. It can be another powder or another binder that you use that reacts with a liquid activator. In our case, we just use water. We can also use seawater or potentially carbonated water, which is allowed to capture the carbon back into the structure. Capturing CO2 in our process is one thing that we wanted to research. We don't have scientific proof yet, but we have two ways. One is the capturing of carbonated water in our structure during the hydration of the cement. And the other solution is during the curing of cement, curing the structure in a rich environment of CO2. But this is a whole new different topic. Let's go back on our binders, which we don't use Portland cement. We try to use marine cement, but our technology allows quite a range of different materials. This range is also resulting in different structure, and the freedom of design allows us to address so many different goals and needs of each environment where we act on. For example, if you need a more bulky structure or more geometrical for coastal protection, you can do that, or interlocking system to have a more dynamic solution. Or for example, a structure that has ledges for the corals to grow because they need sunlight, or a more in-cave for the larvae to settle on and grow protected and safer in an environment. But one of the uniqueness and the particularity of our technology is actually the porosity of the outcome. Because thanks to this technique, we don't cast it, so we don't have this smooth surface of the concrete, but the concrete itself came out very porous. And this allows the nature to really suck in the structure and overgrow and be totally blend in with the natural environment. So we propose multiple solution. Actually, we propose a tool to allow infinite solution for your specific problem. So a tailor-made, custom-made solution that can be produced in location, especially in that remote areas where, to be honest, production of concrete is not really handy to have. These open up also the possibility to involve the communities around your production. So the community can be part of the designing process and the creation of the artificial reef, knowing better what is needed for that environment. It's also raising the awareness of the communities around the marine environment, creating more willingness also to protect the artificial reef that you install in such a delicate natural environment. And also opening up the possibility of concrete to merge and go hand in hand with sustainability and nature restoration. So in conclusion, I'm here proposing a tool that can allow you to have infinite solution to help the ocean to be restored, where we don't actually ship the solution, but we ship the tool, then you can use it wherever you want to create your own solution. yeah, that's including the possibility to use a freedom of design, a freedom of materials, and the awareness of the local communities. Thank you so much.
Thank you.